In this video, we will learn about callable and future in Java. Previously, we have seen that whenever we need to create multiple threads, we used runnable implementation. There are two ways to do it. Either implement the runnable interface and override the run method, or directly we can provide implementation of run method using Lambda expressions. It is very easy and straightforward to define a runnable object. But at the same time, it's very limited because in the runnable execution, we cannot return anything from the thread execution. So what if we want to return a result from our task? In that case, we cannot use runnable. To handle such requirements, Java provides a callable interface, which can return a result from execution of thread. Overall, a callable is almost similar to runnable, except that it can return a result and also it can throw a checked exception as well. Just like we have run method in runnable, there is a call method available in callable interface. Call method will contain the code which will be executed by multiple threads. Here is an example of simple callable implementation. In this, myCallable is a class which implements callable interface and provides the implementation of call method. In the call method, processing will be done and a string type of result will be returned. We can define what kind of data will be returned using Java generics. Like in this example, we have specified string in the angle brackets. That means call method execution will return a string type of result. If you remember, while using runnable, in case we need to use thread.sleep or any other code for which a checked exception has to be handled, then that code we had to keep inside try catch block. But in this case, it's not mandatory because call method can throw a checked exception as well, so that the caller can handle the exception as per their own requirements. So this is the old traditional way of writing callable. As nowadays mostly we write code in functional style, and also callable is a functional interface, so we can use Lambda expressions to provide implementation of call method as well. Now let us see how this same example can be rewritten in the functional style. So this is how Lambda expression can be used to define implementation of a call method where it does not expect any parameters and return the result of string type. Now I hope you are clear with what is callable and how we can code using callable. It is pretty much similar to runnable. For our examples today, we will be using Executor service for task management. If you are not sure about what is Executor service and how to code using Executor service, please check out the videos given in the playlist and link given on the top right corner of your screen. And just like runnable, we can submit callable to an Executor service for execution. But what about the returning result? How will we be able to access it? The submit method of executor service submit the task for execution, but it does not know when the result of that submitted task will be available. Why? Because it's an asynchronous execution. So it returns a special type of value which is called future. A future object can be used to access the result of submitted task when it is complete and result is available. If you have experience of working in front-end technologies such as JavaScript, then you might be familiar with the concept of promise. Future is similar to promise. It represents the result of calculation or processing that will be happening in the future. Now let us see a very simple example of callable and accessing the returned result using future. So in our example, we are using cache thread pool and we have defined one callable and the implementation of call method is given using this Lambda expression. In this, we are using thread.sleep to mimic the processing. And in the end, we are returning a string with the concatenation of result returned from and then appending the name of the thread which is actually executing this call method. And after that, we are submitting this callable to an executor using submit method. This executor.submit method returns immediately a future object. Once we have that future object, we can execute other tasks in parallel while our submitted task is getting executed. Then we are using future.get method to retrieve the result of future. This get method call is a blocking call. That means no other processing can happen in the main thread till the submitted task is executed and returns some value. Here we can see callable task will return a string after the delay of 1 second, which we have defined in thread.sleep. Now let us execute this program and observe the output. Here we can see the submitted task was getting executed in a separate thread but in parallel to the main thread. On accessing the future object, we are able to get some return value from the thread execution as well. This is pretty much straightforward, but in real life applications, there can be more scenarios. So let's try to discuss one small scenario. Suppose if we call an external API in the callable task and that external API service is down, then this future.get will block forever, which will make the application unresponsive. So to handle such scenarios, Future provides an overloaded get method where we can provide a timeout option. Suppose in this case, we provide future.get and then one value, and after that, what is the unit of that particular time. So in this case, we are providing time unit dot seconds. So that means this get method call will throw a timeout exception if the task is not completed within 5 seconds. Now let us discuss one more scenario. Suppose we want to cancel a submitted task. So Future also provides an option for that. We can use future.cancel method to cancel any submitted task. It will only attempt to cancel the execution of the task. If the task is cancelled successfully, then it will return true, otherwise it will return false. We can also provide a boolean argument while calling this cancel method. If we pass the value as true for this argument, then thread that is currently executing the task will be interrupted. And if we do not pass anything, then by default its value is false. And in that case, the in progress task will be allowed to complete. Let us see one simple example of how we can use future task cancellation. So the example is similar to our previous example. Here also we are using a cache thread pool. Then we are defining one callable, and in the implementation of call method for processing mimicking, we are providing thread.sleep, and there we are providing 5 seconds of sleep. And after that, again, we are returning the similar thing with the thread name. Now here using executor submit method, we are submitting this callable and storing the result in future. Now suppose there is a requirement that we need to see after every 200 milliseconds, we need to check whether that task is completed or not. And after, let's say 1000 millisecond or 1 second, if the task is still not complete, then we want to go ahead and cancel it. So to do that, we have this while loop, which is checking whether the future task is done or not. So if it is not done, then we are maintaining this status check counter and it's getting incremented. And also we are printing task is in progress. After that, we are making this thread to sleep for 200 milliseconds. And after that, we are checking if the status check count is greater than 5. That means we have checked the status after every 200 milliseconds more than 5 times. Then we are using future.cancel. This will actually submit the task for cancellation. In the meantime, in the main thread itself, we are doing some other processing as well. Now, in the end, we want to see if the task was cancelled or it was completed successfully. So for that, we have written this logic and used isCancelled method call. So first we are checking if the future is cancelled. So if it is not cancelled, that means it has been completed successfully. Then we are getting the result using future.get and storing it in a result variable and then printing it. Otherwise, if it is cancelled, then we are printing that task was cancelled. So why do we need to do this check of is cancelled? Suppose we do not do this check and directly call future.get. That will result in an exception if the task is cancelled and we are trying to call get on that particular future object. So this is how we can cancel any submitted task. Now in the end, let us just revisit what all methods are available in future from the official Oracle documentation. So this is the official documentation of Oracle where they have given the complete detail about future interface. So in this, let's see what all methods that future is providing us and what is their usage. So the first method is cancel. So as we have just seen, it is used to attempt to cancel the execution of the task, and it also expect one boolean parameter which we can define either true or false, that is may interrupt if running. So if we provide it as true, then the running thread will also be interrupted. Then we have is cancelled method. This actually returns true if the task was cancelled before it was completed normally. Then we have one more method which is done. So this method returns true if the task is completed, irrespective of whether it's completed normally or it is cancelled. In both the cases, is done will return true. Now we have this most used method which is get method. This will actually return what is the result getting returned from the thread execution. So we are able to access that returned value using get method. This can throw multiple exceptions here we can see. So if the thread is already cancelled and we try to call get on that, then it will result into cancellation exception. And in case our execution itself returns some exception during the execution, then it will return execution exception. And in the end, if the currently running thread got interrupted while waiting, in that case, this get call can return interrupted exception. So in the end, we have this overloaded form of get method where we can define a particular timeout. So what it will do, it will wait for that particular time, and if still there is no result returned from the future object, then it will result into an exception. So here you can see in the throws section, we have added one more exception, which is timeout exception. It supports all the other exceptions which are supported in the normal get function. In addition to that, it also supports a timeout exception. So if the wait is timeout, during that time, it will result into an timeout exception. With this, I hope you are clear about Callable, how to create and use them. Also, what is future and how we can use it to manage the returned responses from an asynchronous execution. In the next session, we will see completable future, which is an advanced form of future. If you found this video helpful, don't forget to like, share and subscribe. Once again, thank you so much for watching. I'll see you in the next video. Happy coding!